Good day everyone, I am Juno Alcocer Lola. My topic for today is Spearman's rank row correlation. Spearman rank row correlation. Introduction. The Spearman rank order correlation coefficient, or Spearman's correlation for short, is a non-parametric measures of the strength and directions of oscillations that exist between two variables, measured on a pieced and ordinal scale. It is denoted by the symbol R sub S, or the Greek letter P, or pronounced as rho. Spearman rank order correlation is it assesses how well the relationship between two variables can be described using a monotonic functions. The Spearman correlation between two variables is equal to the Pearson correlation, the last topic we discussed, between the rank values of those two variables. While Spearman correlation assesses linear relationship, and Spearman correlation assesses monotonic relationship, whether it is linear or not. Initiative, the Spearman correlation between two variables will be high when observations are similar or identical for a correlation of 1. Rank, example given, is the relative position label of the observations within the variables first, second, third, and etc. between the two variables, and low when observations are similar or fully opposed for a correlation of -1. Rank between the two variables. The Spearman correlation coefficient is defined as the Pearson correlation coefficient between the rank variables. Spearman correlation formula is rho is equal to -1 and 1 negative 6 sum of the difference between the two ranks of each observation over n times n squared minus 1. The P here is the Spearman rank correlation, or as we pronounce as rho. The DI is the difference between the two ranks of each observation. It means the difference is the rank 1, and the rank of x and the rank of y is, we need to get the difference of n, and n is equal to the number of observations. Example number 1. The raw data in the table below is used to calculate the correlation between the IQ of a person with the numbers of hours spent in front of the TV per week. The IQ of the person is 106, 186, 101, 99, 103, 97, 113, 112, 110. Hours TV per week, or our x variable is our second variable, or the y variable. 7, 27, 2, 50, 28, 29, 20, 12, 6, 17. Firstly, we need to evaluate the difference between the two rank observation. To do so, use the following step reflected in the table below. First, we need to sort the data by the first column, or the x, then create a column in a x sub I and assign it to the rank values as 1, 2, 3, and so forth and so on. Second, next, to sort the data by the second column, or our second variable, create a fourth column, and this is our y sub I, and similarly assign in the rank values as 1, 2, 3, so on and so forth. Third, create a fifth column that name as d sub I, to hold the difference between the two rank columns, our first variable and second variable. And lastly, create one final column as the difference of the two rank variables, to hold the value of the column di squared. This is the output of the steps that we talked about earlier. First, we have the x variable. Second column is the hours of TV per week, and we need to rank the x. And this is 1. 86 number is rank 1, 97 is rank 2, 99 is rank 3, 100 is rank 4, 101 is rank 5, and so on and so forth. The same in ranking in the variable y. We need first to define where is the in defining the rank of the variable. We need to rank it by lower to higher. So the number 2 in the variable y is the first. The 20 is the rank 6, because there is a smallest number before 6, and that is 6 here in the second to the last of the column and the row, that is 2. So the 28 here is the rank 8, the 27 is the rank 7, the 50 is the rank 10, the 29 is the rank 9, the 7 is the rank 3, the 17 is the rank 5, the 6 is the rank 2, the 12 is the rank 4. In getting the di b sub I, we need to subtract the rank of the x variable and the rank of the y variable, and this is what we get. 1 minus 1 is 0, 2 minus 6 is -4, 3 minus 8 is -5, 4 minus 7 is -3, 5 minus 10 is equals -5, 6 minus 9 is equal -3, 7 minus 3 is 4, 8 minus 5 equals 3, 9 minus 2 equals 7, 10 minus 4 is equal to 6. Then in getting the di squared, we need to square the difference that we get in getting the difference of the ranks, of the observation of the ranks. That's why 0 squared is equal to 0, -4 squared is equal to 16, -5 is equal to 25, -3 is equal to 9, -5 squared is equal to 25, -3 squared is equal to 9, 4 squared is 16, 3 squared is 9, 7 squared is 49, 6 squared is 36. And that is how we get the di squared. And to get the rank, the experimental correlation, we need to use now the formula of the with the di found, as well as I said, if the di is found, the di squared is found, add them and find the sum of the di squared, and this is what is equal to 194. Value of our n is 10, and this the value can be substituted back into our equation or our formula, and this is our formula. Rho is equal to 1, -6, and the sum of the difference over the n times n squared minus 1. Then substitute. Rho equals to 1, -6 times 194, our difference of observation rank. Our n is 10, then times 10 squared minus 1. Then, which evaluates that that rho is equal to -29 over 165. And -29 over 165 is equal to -0.17575757.5, and so on and so forth, with a p-value of 0.627188 by using the t distribution. And this is how, and therefore that the value is close to 0 shows that the correlation between IQ and hours spent watching TV is very low. Although the negative value suggests that the longer the time spent watching television, the lower the IQ. In this case of ties in the original values, this formula should not be used. Instead, the person correlation coefficient should be calculated in the ranks, where ties at giving ranks as described above. To understand well the experiment correlation, I will give more examples. Example number 2. The scores for 9 students in physics and math are as follows. In physics, he or she got 35, 23, 47, 17, 10, 43, 9, 6, 28. In mathematics, he got 30, 33, 45, 23, 8, 49, 12, and 4, and 31. Then compute the questions is compute the students' rank in the two subjects and compute the experiment rank correlation. So we need still to follow the steps that we discussed before. First, we need to find the ranks for each individual subject. I use the Excel rank function here to find the ranks. If you want to rank by hand order or the hands from the score biggest to smallest, that is really fine. As well as will you are comfortable. Assign the rank 1 to the highest score and 2 to the next highest, and so on and so forth. In physics, you got 35, and that's our x variable, and that is rank 3. And then in math, you got 30, and that the math is our y variable, and that was rank 5. Physics is 23, rank 5, 47, rank 1, 17, rank 6, 10, rank 7, 43, rank 2, 9, rank 8, 6, rank 9, and 27, and 28 is rank 4. 30 is rank 5, 33 is rank 3, 45 is rank 2, 23 is rank 6, 8 is rank 8, 49 is rank 1, 12 is rank 7, 4 is rank 9, 31 is rank 4. Here in our example, then to the earliest, we here use the greatest to highest. Then also it's okay to use the lowest to highest. Depends on you what were you comfortable with. Second, add a third column or the D or our D to your data. The D is the difference between the ranks. For example, the first student's physics rank is 3 and maths rank is 5, so the difference is 2 points. The same as what we do in our first example, we need to find the difference between the two ranks of the two variables of our observation. In the fourth column, square your D values. The same as what we used to do in the earlier example. 33 minus 5 is equal to 2, and 2 squared is 4. 5 minus 3 is equal to 2. 2 squared is 4. 1 minus 2 is 1. And 1 negative 1 is this square. 1 squared is 1. Then 6 minus 6 is 0. 0 squared is 0. 7 minus 8 is 1. And 1 squared is 1. 2 minus 1 is 1. 1 squared is 1. 8 minus 7 is 1. 1 squared is 1. 9 minus 9 is 0. 0 squared is 0. 4 minus 4 is 0. Then 0 also is pair. So we complete our table, so we can find now the Spearman correlation by using our equation. But first we need to sum up or add up all our d squared values, and this is 4 plus 4 plus 1 plus 0 plus 1 plus 1 plus 1 plus 0 plus 0 is equal to 12. Then we need this for your formula to find the sum of the d squared in just the sum of the d squared values. Then lastly, insert the values into the formula. So substitute, these ranks are not tied, so use the formula. Formula here again is the rho is equal to 1 minus 6 times sum of the di squared over n times n squared minus 1. Then substitute. P1 is rho is equal to 1 minus 6 times 12 over 9 over n. Then 9 squared is equal to 81 minus 1. Then multiply using the PEMDAS. 6 times 12 equals to 72. Then 81 minus 1 is 80 times 9 is 720. Then divide then find the quotient of the 72 minus 722 is equal to 0.1. Then our rho is equal to 0.9. Then therefore the Spearman calculation for this set of data is 0.9. Then we need to go over further example. Example number 3. Calculating a Spearman rank order correlation data without any ties we use the following data. Then we use the English marks as 56, 75, 45, 71, 62, 64, 58, 80, 76, 61. And maths marks is 66, 70, 40, 60, 65, 56, 59, 77, 67, and 63. Then we need to complete the following table. As the rank, we need to find the rank of each number of maths and English marks. The English mark of 56 is his rank in this table is 9, the 75 is 3, the 45 is 10, the 71 is 4, the 67 is 6, the 64 is 5, the 58 is 8, the 80 is 1, the 76 is 2, the 61 is 7. The rank of maths in this table is the 66 is rank 4, the 70 is rank 2, the 40 is rank 10, the 60 is rank 7, 65 is rank 5, the 56 is rank 9, the 59 is rank 8, the 77 is rank 1, the 67 is rank 3, the 63 is rank 6. Then we need to find the D. The D is the difference between the two ranks we find. And 9 minus 4 is 5, 3 minus 2 is 1, 10 minus 10 is 0, 4 minus 7 is 3, 6 minus 5 is 1, 5 minus 9 is 4, 8 minus 8 is 0, 1 minus 1 is 0, 2 minus 3 is 1, 7 minus 6 is 1. Then we need to find the D squared. We just need to square the value of the D, the difference of the two ranks. 5 squared is 25, 1 squared is 1, 0 squared is 0, 3 squared is 9, 1 squared is 1, 4 squared is 16, 0 squared is 0, 1 squared is 1, 1 squared is 1. Then we need to, now we have these values, the D and the D squared. Then we need to find the sum of the difference of the D squared. Then add all the values of the D squared. 25 plus 1 plus 9 plus 1 plus 16 plus 1 plus 1 is equal to 54. Then the sum of our D squared is 54. Then we have these values. Then we need to calculate and substitute this into our main equation or our formula with the other information as follows. This is our formula. Rho is equal to 1 minus 6 times the sum of the D minus D squared, sum of the D squared, over n times n squared minus 1. Then substitute our given equation. Then rho is equal to 1 minus 6 times 54, our D squared, then 10, our n, or the number, then times 10 squared minus 1. Then 6 minus 54 is 324, then 10 times 10 squared is 1000, minus 1 is 9, 10 squared is 100, minus 1 is 99, 99 times 10 is equal to 990. Then find the quotient of the 324 over 999 is equal to 0.33. Copy the sign. 1 rho is equal to 1 minus 0.33. Then rho is equal to 0.67. Then therefore we have a rho, or the R sub S, or our Spearman correlation of 0.67. This indicates a strong positive relationship between the ranks individuals obtained in a maths and English exam. That is, the higher rank in maths, the higher rank in English. Example number 4. An examination of 14 applicants for accountant post was taken by a finance company. The marks obtained by applicants in the reasoning and aptitude test are given below. Our applicant, we name the applicant as alphabet A, B, C, D, E, F, G, and K. Then the reasoning test is our X variable, and the aptitude test is our Y variable. Applicant A, he got the reasoning test of 20 and aptitude test of 30. Applicant B got the reasoning test of 50 and aptitude test of 60. Applicant C got the reasoning test of 28 and aptitude test of 50. And applicant D got reasoning test of 25 and aptitude test of 40. And applicant E got 70 reasoning test and 85 aptitude test. Applicant F got a reasoning test of 90 and aptitude test of 90. And our applicant G got 76 in reasoning test and 56 in aptitude test. Our applicant H got 45 in reasoning test and 82 in aptitude test. Applicant I got 30 in reasoning test and 42 in aptitude test. Applicant G got 19 in reasoning test and got 31 in aptitude test. And applicant K got 26 in reasoning test and 49 in aptitude test. Then calculate the Spearman rank correlation from the data given above. Then we need to find first the rank of each variable of this given data. Our applicant ABC, D, E, F, G, H, I, G, K got the reasoning test, or our X variable, 20, 50, 28, 25, 70, 90, 76, 45, 30, 19, and 26. And the aptitude test, or our Y variable, is 30, 60, 50, 40, 85, 90, 56, 82, 42, 31, and 49. Then we need to find each rank of our X variable. The 20 he is in the rank of second. The 50 got the rank of 8, 28 got the rank of 5, 25 got the rank of 3, 70 got the rank of 9, 90 got the rank of 11, 76 got the rank of 10, 45 got the rank of 7, 30 got the rank of 6, 19 got the rank of 1, 26 got the rank of 4. Just be used where you're comfortable. You will rank this data, given data, it is to higher or lower, or lower to higher. Then we need to find each rank of the aptitude test, or our Y variable. The 30 is the rank 1, 60 is the rank 8, 50 is the rank 6, 40 is the rank 3, 85 is rank 10, 90 is rank 11, 56 is rank 7, 82 is rank 9, 42 is rank 4, 31 is rank 2, 49 is rank 5. Then we need to find the difference, or our D. We just need to get the difference by getting the difference of the two ranks of the two variables. 2 minus 1 is 1, 8 minus 8 is 0, 5 minus 6 is negative 1, 3 minus 8 is 0, 11 minus 9 minus 10 is negative 1, 11 minus 11 is 0, 10 minus 7 is 3, 7 minus 9 is negative 2, 6 minus 4 is 2, 1 minus 2 is negative 1, 4 minus 5 is negative 1. Then we need to get our D squared. We just need to square the value of our D. That 1 squared is 1, 0 squared is 0, negative 1 squared is 1, 0 squared is 0, negative 1 squared is 1, 0 squared is 0, 3 squared is 9, negative 2 squared is 4, 2 squared is 4, negative 1 squared is 1, negative 1 squared is 1. Then we need to get our sum of our D squared. Just add all the value we got in D squared, and that was equal to 22. Then the rank correlation is given by, this is what our formula is. Rho is equal to 1 minus 6 times the sum of the D squared over n times n squared minus 1. Then substitute all the given data. 1 minus 6 times 22, the sum of our the sum of our D squared, over 11, our n, times 11 squared minus 1. Then multiply the 6 times 22 is equal to 132. Then 11 squared is 100 133. Ay, no. D squared minus 1 times 11 is equal to 1,320. Then, find the quotient of the 132 over 1,320. That is 1 over 10. Then find the difference of 1 minus 1 over 10 is equal to 0.9. Then our Spearman-Rank correlation is 0.9. Then, last example number 5. A random sample of recent repairs job was selected and estimated cost and actual cost were recorded. Estimated cost of X variable is 300, 45, 800, 2,250, 500, 975, 475, and 400. And our actual cost is 273, 486, 734, 297, 631, 872, 396, and 457. Then calculate the value of Spearman's correlation coefficients. This is the same as our procedure in the earlier example. We just first need to find the values of or the ranks of each variables and our estimated cost or our X variable. The rank of the 300 is rank 2, the rank of 450 is 4, the rank 7 is 800, 250 is in rank 1, 500 is rank 6, 975 is rank 8, 475 is rank 5, 400 is rank 3. Here we just still use the lowest to highest ranking. Then next we need to find the rank of the actual cost or our Y variable. 273 is our rank 1, 486 is our rank 5, 734 is rank 7, 297 is rank 2, 631 is rank 6, 872 is rank 8, 396 is rank 3, 457 is rank 4. Then next we need to find the difference of two ranks of the two variables. We just need to minus each other. 2 minus 1 is 2, 4 minus 5 is negative 1, 7 minus 7 is 0, 1 minus 2 is negative 1, 6 minus 6 is 0, 8 minus 8 is 0. 5 minus 3 is 2, 3 minus 4 is negative 1. Then, in getting the difference of the D is, we just need to square the value of our D. 1 squared is 1, negative 1 is squared is 1, 0 squared is 0, negative 1 squared is 1, 0 squared is 0, 0 squared is 0, 2 squared is 4, negative 1 squared is 1. Then, find the sum of our D squared. Just add all the sum or the value of our D squared, and we got that value of the sum of the value of the squared is equal to 8. Then find the Spearman-Rank relation by giving our formula. Rho is equal to 1 minus 6 times the difference of the RD squared over n times n squared minus 1. Then substitute all the given data. 1 minus 6 times 8, or 8 is our sum of our difference is d squared. Then 8 is our n. Then 64 is the square root of 8 minus 1 is equal to 6 is equal to 6 over 63. 1 minus 6 over 63, we already here find we just reduced already here the equation. Then minus the difference. 6 over 63 is 0.095. Then minus it into 1. Then our rho is equal to 0.905. And this is our Spearman-Rank correlation of the given data earlier. And this is the end of our discussion for the Spearman-Rank correlation. Thank you for listening and have a good day.